Hello YouTube. New phone, new camera. Awesome. Anyway, I have a big huge mess. I got curious one day and was like, I wonder if they'll charge faster if I switch over to 24 volt. Now, as you guys know that have been watching the channel, I'm not using the standard charge controller that is meant for lead acid batteries. No, I'm not doing it. Refuse. That's not how they're supposed to be charged under constant voltage. So, okay, here's what happened. The maximum output voltage under no load is about 22 volts per panel. Well, yeah, 22 volts at 12 volt. That's no load. So I switched over to 24 volt. Under a load I was fine, but when the batteries got fully charged, guess what happened? That 22 volt turned out to be 44 volts and blowed out the boards that I'm using to charge. I was able to recover this one. MOSFETs blew out of it, but this one went to straight 40 volts. Both of them did. And they shot the 40 plus volts into the batteries. The BMS boards tried to save the batteries, but that was a lot of voltage to handle. Lesson to learn: don't ever try to charge in this manner these batteries at 12 volt using 24 volt setup. I have had to rebuild every single battery pack because I ended up with a bunch of them at 0 volts. Now, to pause this and we'll be in the kitchen. After getting all battery packs, turn this light on here. Help a little bit, but not much. After getting all 9 battery packs tore down, retested the capacity, a lot of them lost 50% of the capacity that they had. Some it didn't bother, some it completely ruined them. I got one here that was 1505 is what it tested at as capacity, and this is a full river cells. And then ended up testing at 871. I've got a whole pack of, it's 6 going this way, so it's 18 cells at 4S. So this is all crap. Every one of these is 1100 or lower. Now when I went back and rebuilt my packs, I did a tight volt capacity setup where it was 1200 to 1600. Everything seems to be working out okay. I've only got that one board. I've got another one to replace the one that went completely bad. But moral of the story, if you're going to use the method that I'm using, don't try to use 45 volts or 44 volts to charge the batteries. May work for a standard charge controller if you guys want to go that route, but I can tell you, constant voltage is not the way these cells are supposed to be charged. It is constant current, constant voltage, and changing those boards out is really no problem at all. It's not. You just pull the MOSFETs out, lay them down flat, mount the board onto a decent heat sink, and it'll stay cool, and you'll be able to get right at 30 amp out of the board itself. But I'd recommend not going over 25. And that's due to the current on the output side and the wire you're limited on how thick you can go with the wire. It's about 14 gauge. That does get hot. And if it gets hot enough and you've got anything soldered, then you'll end up melting the solder if it gets hot enough. So I've got a bunch of cells. This one pack, it's pretty much just going to be a loss. I don't have enough cells to really make another pack. I'm pretty close to this one, but it's only like 12 amp, well, 14 amp hour, and I'm not trying to go below 18. And adding these lower capacity cells in with that, and they're anywhere from 1200 up to 17. I don't want to drop any lower than that. I want to try and keep them within like 500 milliamp hour. And it's actually working out better. The packs are charging out evenly. No cells lingering behind because they're really high capacity. So, you know, I had something good turn out for something bad. I was able to get all the cells sorted out. The misfortune is having to do this to get 18 amp hour. And hopefully I can still get plenty of cycles left out of them. Some of them did overheat. I ended up with cells with 0 volts. Put a blue line on them to let me know, hey, that's a 0 volt cell. And how I recovered it was sticking a screwdriver down that little bitty hole. You can see the crease there. There's a hole in there. It's a small straight screwdriver. And you gotta watch what you do. If you run at it too hard and too firm, you'll end up popping it and you'll hear a hiss, and that cell's bad. Because after it gets through cycling, it'll end up drying out and completely just lose all its capacity. So the ones that I popped, I tossed, had to set aside. I think I ended up popping maybe 20 cells. That's partly why I don't have enough cells to finish one last pack. I got this one. All these cells are like 8 to 1100. But I really don't want to go below 8. Below 8 is just scrap. But anyway, I'll give you guys another preview on how I'm charging. Okay, these are the 20 amp constant current, constant voltage boards. This one is left for, I was able to repair it. This one, no. I tried to change the MOSFETs in it. The capacitor's actually blue also. I changed the MOSFETs in it, and no, it's still not working. It was bypassing straight 40 volts, and I'm like, nope, you gotta go. So this one's okay. I can get about 25 amp charge on 1, 2, 3, 4, 5 packs. On 5 packs. I used to have 9. So yeah, that's a pretty big loss. Okay, alright, just a heads up, if you want to charge these this way, just keep in mind, charge with 12 volt, not 24. And these boards are absolutely great. They've been very reliable. Except for the last batch that I tried to buy, I ended up getting 5 that were defective. But I ended up getting 3 good ones. And when you get them good, they're reliable. Just got to keep them cool if you're going to run them at 25 amp. That was the whole purpose of this big aluminum heatsink. I wanted to make sure, and I've even got a fan on the back side of it. Okay guys, I'll catch you later. That's an update on this entire setup. It's working good, but I got sidetracked. Oh, one other thing. Latest build. 3D printed 18 650s 4S with a voltage regulator on the output. Now when you guys are doing this, you just got to keep in mind these will only do about 10 amp, 15 max, and that's on surge. They do have a limiter in them, protection limiter, but 10 amp they hold stable. And the current that's being drawn for the power that you're using from the inverter comes from the sum of all parts. So that's my input for the charge, direct to the batteries, charged to 16.8, and the output voltage, I added a Schottky diode, transistor style, added a heatsink to the back of it, and this goes to the inverter for my power. This works. It's been working great. I took them out because I need to work on that shelf and get that new regulator put in. I've got 2 of those packs and then 1 of the old style. I've actually rewired all my packs in a different manner, which is going, basically it's taking 4 1S packs and then getting them bonded together to get them to work. Been doing great. Absolutely. But anyway, there you go. Hope you learn how to be safe. Thank you. I'll catch you later.